Hi everyone, welcome to another video, and today we're going to discuss about a new question called kth missing positive number. So the question states that given an array of positive integers sorted in a strictly increasing order and an integer k, return the kth positive integer that is missing from this array. So let me explain the question on the whiteboard. So now then, let's consider the example one. So example one is an array starts from 2, then 3, then 4, 7, and 11. And k is given as 5. So it says that our array is the integer, positive integer array starting, then it should start from 1, right? The first missing character is 1. Then there is nothing missing between 2 and 3, nothing missing here. Then 7 and 4 missing characters are 5 and 6. Now then, after 7, the missing numbers are, we can say, like uh, mm, 8, 9, and 10. Now then, if you see the fifth missing character or fifth missing number is 1, 2, 3, 4, 5. That is 9, right? So the simplest way to calculate this is like uh, creating a number like from 1 to 11 plus 5, that is 16, right? So we're gonna get the number 16. Then we're gonna loop through from 1 to 16. We're gonna loop through from 1 to 16. So why 16 is, it is possible that, for example, the k may be um, uh, more than the, for example, here, see, k is fifth, so we get 9. Then what if we get a k8? If we get a k8, then k will exceed the length of our given array, so it should be calculated after that. So I am just so if we can iterate through the number, so we're gonna get the last number, that is 11, plus k, that is 16. Now what you're gonna do is we're gonna iterate or loop from 1 to 16, and we'll see if any number that is index, right, or I plus 1, we can say, is present in this given array. If present, we just have to skip. If not present, we just have to increase a count by 1. We're gonna declare, we're gonna initiate a count with 0, and every time we don't find a number from the range inside our array, we just going to increase the count plus plus. And when our count becomes k, we just have to return the index, this number from the our number loop, and that will be the answer. This is the simplest one, and it will be like OFN complexity. But this problem can be solved using a binary search, because this is like a sorted array, and this can be solved as a binary search. Why binary search? Because we just have to get the number. Because um, here you see, the last here, the 0, sorry, 1, 2, 3, right? When we reach to 7, our number of k, or number of missing character, is 3, right? And that is less than k. And if you go to 11, our number of missing character become more than 5. So we just have to uh, get the number where last time the k is less than 5, and then we just have to um, reduce or subtract the missing number of missing character at that position from k, and add that to the number, right? Let me explain that in a better way. Now the missing character, how are we going to calculate the missing character? So since the array is in increasing order, from and it expecting like and it expecting us to start from 1, then continuously go through 11, right? That's what the expectation is. And anything missing here, that is the number missing. So if the array is, if the array or if the given array has no missing character, then our index and the number should be matching, right? If there is no missing character, for example, 1, 2, 3, 4, and so on, you see that our 0 index will be 1, 1 index will be 2, 2 index will be 3. So there is a sync, they are sync with the index. Okay, so if you make plus 1 here and then subtract, then we're going to get the missing character here. Because it is a continuous array without any missing, we're going to get only zeros. Using the same formula here, right? Let's write down the index 0, 1, 2, 3, and 4, right? And if we have to start from 1, so we're going to add 1 here, plus 1, plus 1, plus 1, plus 1. So this is like what? 1, 2, 3, 4, and 5. So what will be the missing character here? 2 minus 1. Missing is 1 because 1 is not there. It expecting 1 to be present at first index, but it's not there. So we can find it. Same way here, the number of missing 1, number of missing 1. Here the number of missing is 3, and here the number of missing is 11 minus 5 is 6 numbers, right? So here the number of missing character became more than 5. Okay, then we have to find the previous number, that is here this index 3. Then how much we should be adding to the 7? The 5 minus 3 is equal to 2. If we add 2 to 7, we'll get 9, and that will be the answer. But now to find this 7, right, we can now implement binary search, and that will reduce our problem to n log n, OF log n, right? So we're gonna now start our ith index here, right? And jth index here. And then we're gonna find our mid. And if mid is less than, less than 5, then we're gonna increase our I to mid. And if mid is greater than 5, then we'll reduce the left index to the mid. And by doing that, we're gonna at one point we're gonna find the left index. And at that time, because we're gonna, if we move like left equal to mid plus 1, right? Because by the time we get to this index, if we move left index to mid plus 1 and right index to mid minus 1, and by the time we get here, our index will be 0, 1, 2, 3, 4, right? Because plus 1, so it will become 4. Then we just have to add k to that index and we'll get the number, the result. And this will also gonna work if our k value is the kth value falls outside the given array, because at the end our left index will become the last one, and then from there we just have to add 2 more. For example, let me show you this example. There is another example like 1, 2, 3, 4, and k is 2. So here there is no missing character. So at the end, L become 2, and our result will become like 4, 0, 1, 2, 3. Last index will become 3 plus 1, right? 4. Then 4 plus 2 is equal to 6. 6 will be the answer. So this solution will work in every case. So now let's implement the solutions using JavaScript. Now then, let's implement the solutions using JavaScript. So create the function find get positive number. Gonna take our array in k, right? If we implement the first solution, which is the easy one, we just have to uh, let calculate the range. Range will be like array of array dot length minus 1 plus k, right? This will be the one, and then k plus 1, we have to increase it 1 plus 1, because we're going to start with from 1, right, not 0. And then we just have to run a for loop for like let I, then I equals to 1. We're going to start from 1, and array dot length, not array, we're going to less than range I plus plus, right? Now what we're going to do here is like if array, that our input array dot includes I, because you're gonna just have to check the index, because we're gonna start from 1, we just have to check the index. So if index present, we don't have to do anything, we just have to continue. And then if not, we just have to make our count plus plus, count plus plus, right? Let's initiate our count. Let count equals to 0, and yeah, if count equals to k, then we just have to return I. Simple. This is the simplest solution, OFN, and it will work. Now let's go to our test case and try to run it. You see it runs perfectly. Now let's go for our the binary search solution. Make it 2 then. Okay, so here what we're gonna do is let I, we're gonna initiate our 2 pointer, left and right. Let's create left and right. Left and right equals to 0, and array dot, sorry, array dot length minus 1. Perfect. Now then let's create a method like let get diff equals to, gonna take our index, and it will return us array of I minus I plus 1, right? So if you give a index, it's just gonna go there and subtract the index plus 1 from the array value, and in that way you're gonna find the missing character for that particular index. So we're gonna use that in our while running our while loop. So now while I less than equals to j. Let mid equals to math.floor. Now left plus right by 2. This will give us the mid index. And then we're going to write our if get diff mid, right, less than k. Then we're going to move our not I, this is left and right, left and right. So our left will become mid plus 1, else right become mid minus 1. Perfect. So at the end of while loop, our left index should be at the correct index plus 1. So we just have to add our k to that particular index and return the value. So return left plus k, and this should solve the question efficiently. Now let's try to no, we have to again and module.export export this as well. Perfect. Now I can do it here. Let's run it. Boom, perfect. Now let's try to run this in our Leet code and see what happens, right? So we're gonna go here, open the Leet code. Now let's run our, let's copy both so that we can see how the efficiency got affected in both the solution. Okay, so because this is the correct name, it will run this one first, this one. So let's run it. So it got all the test cases is passed. Now I'll be submitting it. So you see the efficiency came here. Now let's run the binary search one and see how it affects the efficiency. And let's run it here. Test case are passing. Let's submit. Perfect. See, the efficiency has increased substantially when we use our binary search method. So that's that. That is the different way to solve this question. So hope it helped you, and thank you so much for watching.